Hello and welcome to G Fun Facts Online, the show that dives deep into the science and engineering shaping our world in surprising ways. Today, we're talking about a topic that's hiding in plain sight: the homes of millions of people who build our cities, harvest our food, and power our economies. I am talking about migrant workers. They are the essential thread in our global society, but they often live in the most dangerous places, facing the full force of climate change. So how do we protect them? The answer lies in some truly brilliant engineering. This isn't just about building houses, it's about engineering lifelines. Let's get into it. Think about the last building you saw being constructed, or the fresh fruit you bought at the market. The hands that made that possible often belong to migrant workers. Yet, the places they call home are frequently located on the fringes, in areas prone to floods, earthquakes, and cyclones. The housing itself is often built on the cheap, lacking the basic strength to withstand a disaster. The COVID-19 pandemic threw a harsh spotlight on this, showing how overcrowded conditions could accelerate a health crisis. When disaster strikes, these communities are hit the hardest, losing not just their homes but their livelihoods, and sometimes, their lives. It's a massive, unseen crisis, but engineers are stepping up with a blueprint for resilience. So, how do you build a house that can stand up to an earthquake, a cyclone, and a flood? Let's start with the shakes. In earthquake zones, the key isn't to be rigid, it's to be flexible. Engineers are taking inspiration from traditional building styles like bahareke, which uses timber or bamboo frames. They're upgrading them with modern science. This means reinforced concrete foundations, walls strengthened with a mesh that helps cement cling to the frame, and crucially, lightweight roofs. A heavy roof is the most dangerous part of a house in an earthquake. A project in El Salvador proved that a low-cost house built with cane, timber, and cement could withstand severe seismic activity. They even tested a full-scale model on a shake table. It's incredible stuff. Now, what about wind? Cyclones are like giant bullies trying to rip a house apart. The engineering solution is to get aerodynamic. Simple, compact, and even circular or octagonal buildings perform best. For a standard rectangular house, just rounding the corners can make a big difference. The roof is key here too. A pyramid-like hip roof is much more stable than a simple triangular gable roof. And every single part of the house, from the foundation to the walls to the roof, needs to be securely strapped together. Case studies from Fiji show that traditional houses with these features have survived monster cyclones. And then there's water. For floods, the simplest solution is often the best: get up high. Elevating a house on stilts or columns is a classic and effective strategy. But you also need to waterproof the foundation and use water-resistant building materials. It's about keeping the living space dry and functional, not just during the flood, but after it too. It's not just about surviving sudden disasters. What about the slow-burning crisis of extreme heat? Millions live in homes that become dangerous ovens during heat waves. The answer isn't just to crank up the AC, which many can't afford anyway. The smarter solution is passive cooling. This is design that works with nature, not against it. The single most effective tool? Good insulation, especially in the roof. Next, think color. A simple coat of sun-reflective white paint can dramatically reduce how much heat a building absorbs. Then there's clever design for cross-ventilation and shading from overhangs or even trees. Organizations like the Mahila Housing Trust in India are training communities to install these simple, low-cost solutions, making homes safer and more comfortable in sweltering heat. But a resilient house is useless if it's an island. It needs to be connected to a network of essential services. Access to clean water and sanitation, what experts call WASH, is a fundamental human right. Innovative programs are now working to create water systems that serve both migrant workers and their host communities, fostering peace and shared resources. The same goes for energy. Many resilient designs now incorporate renewable energy, like solar panels, providing reliable power for lights and cooking. And we can't forget transport. Locating housing on the extreme edges of cities means long, expensive commutes. Resilient planning means thinking about access to affordable public transport and even digital connectivity. These engineering solutions are brilliant, but they need a supportive ecosystem to flourish. First, we need strong policies and building codes that are actually enforced. These codes are the minimum safety standards, and they need to account for climate resilience. Second, we're seeing a revolution in building materials. Forget just concrete and steel. We're talking about high-tech bamboo, which is strong, sustainable, and disaster resilient, or hemp, a material that actually absorbs carbon as it grows. Researchers are also developing low-cost composites from foamed concrete and even recycled materials. But the most important piece of the puzzle is the people. The most successful projects are human-centered. They involve residents in the design process, respecting their culture and understanding their needs. It's about combining cutting-edge engineering with a deep respect for human dignity. So the next time you think about global challenges, remember the invisible homes of migrant workers. Building safe, resilient housing for them isn't just a social responsibility. It's one of the great engineering challenges of our time. It's about designing structures that can withstand earthquakes, cyclones, floods, and heat waves. But more than that, it's about building a foundation for a more just, equitable, and sustainable future for everyone. Thanks for tuning in to Fun Facts Online. Join us next time as we uncover more amazing science and engineering that's changing our world.